Hello, and welcome to Dr. C. Brady's Science Extraordinaire. On this episode of Startling Science. Dr. Brady, seen here in his office, is a scientist dedicated to bringing you the wonders of the brand new fields and new discoveries of science. What will he do today?
Welcome to Startling Science. Today, we will observe as a seemingly solid candle begins to melt into a liquid. The candle's particles are sliding past each other as I turn up the heat. Startling, isn't it? Make sure to... What are you doing in my lab?
It's a little Frosty showtime now. You irrelevant.
States of matter that we're going to focus on are solids, gases, and liquids. In all states of matter, atoms are moving. They just move in different ways based on what state they're in. The atoms in solids are tightly compacted. They stay in a place and basically vibrate next to each other. The atoms in liquid are a tad more loose. This causes liquids to slide past each other and take the volume of the container that they're placed in. The atoms in gas are in constant motion and whiz past one another, so they don't have a definite volume. There's actually another state of matter that is much more rare. Plasma! Plasma is the stuff that makes up stars. The matter is actually so energetic, the electrons separate from the nuclei and create intense heat and light. Two major factors are involved with the changes of states of matter are temperature and pressure. Temperature is a measure of average kinetic energy of the particles in a sample matter. Pressure is force applied per unit area. Temperature heating up causes the atoms to move faster and faster while spread out until all of a sudden they change phase. Pressure also plays an important role. Pressure can hold things together even when they get hot enough to change states. And every substance is different. Here, let me show you what I'm talking about. Here's a graph for pressure and temperature. This bit is solid, this bit is liquid, this bit is gas.
What about that point, Josiah?
Oh yes, that point. That is called the triple point. The substance can be solid, liquid, gas at the same time. And here at the critical point, the substance can be liquid and gas.
Hello! Today we'll be examining a lesser phase change called sublimation.
Sublimation is the process in which solids can become a gas, skipping the liquid phase entirely.
This dry ice, or frozen carbon dioxide, is sublimated. Its molecules are splitting out of solid form and becoming a gas due to the temperature being high above its melting and evaporation phase.
You can sort of see the process happening if you look closely, but you'll be able to see it a lot more if I put it in this warm water. Isn't that cool?
Now that you know how phase change works, let's take a look at them. These molecules are vibrating against each other, but they're mostly staying in the same place. Now heat increases the molecules to begin a shake so much that they slide past each other. Now this substance is fluid. Even as more heat is added to the atoms, the substance begins to separate from each other and becomes gaseous.
Consider the following.
When substances change phases, their relative density is almost always changes in the same way. For instance, liquid mercury is more dense than its solid companion, so it sinks itself. Water, on the other hand, works strangely. Water is frozen into ice. The ice is less dense than liquid water, allowing ice to float on water. The little difference does a whole lot in the natural world, allowing the North Pole to exist and ice sheets to form.
So what did you need to take away from this? Well, the three states of matter that we covered are different based on the way their particles move. Temperature isn't the only thing that influences what state of matter an element is in. Pressure also plays an important role. We also talked about sublimation, which is a phase change that you don't typically see. Finally, we learned about some interesting things involving the special phase-changing properties of water. Got all that? Good. See you next time on Lil Frosty, the Science Student.